Okay, hello everyone. Today, let's take some time and go through Matlab. And a brief introduction is some of the integrated development environment views that you'll see, how to navigate, and a few of the features that will get you up and running. So to begin, this is a brief overview. It's a good reference if you want to know what's in the PowerPoint. Hopefully you can use this to help with homework, to study, anything like that. So we're going to start off with the basics, work through some variable declaration, vectors, other data containers, and into reading in files and saving them. So when you finally get your Matlab installation up and running, this is going to be what your main window looks like while you use the program. A couple things to focus on are the file tree over here on the left, browse files here. This is where you will connect to folders and paths on your computer, or perhaps if you're using Dropbox, you'll set the directories here and be able to create subfolders as well for different projects so that you can stay organized. On the right, this is going to be your workspace variables, which will be assigned as you execute them down here in the command line, or as you write scripts or functions up here in the editor window. Additionally, note the two arrows, that is the command prompt, and when you run a particularly long command, that will go away, and that means it's running, and when it finishes, it will return. A quick aside, if you press Control-C or even hold that, that will stop an execution that may be taking too long or stuck in a while loop or something like that. So when those arrows return, that means you can write another line of code. So to begin with something simple that we're going to need right away is numerical expressions and creating variable names. Variables are a simple way within Matlab that we can store data in a way that we can understand it later on, just like any other variable that we'd work with. So key points to focus on. First one being that Matlab must start with a letter of the alphabet. There are case sensitive, so if you make a typo somewhere, that could be a problem. And there are certain keywords that you don't want to overwrite. For instance, the word continue, if you look over here, this one's in blue because Matlab recognizes it as one of its own. So be sure you don't overwrite that. Additionally, the assignment operator is what will be used to link the value or string or whatever piece of data that you're passing to the variable name. And the semicolon is used to suppress output. So I'll show an example of that momentarily. So just getting back to this would be a couple examples of fine variable names. You can use characters if they follow the letter. Same thing with numbers. I like this camelback style where this would say variable number 1 and an O are capitalized. These are improper methods. Additionally, a couple bullet points. Once a variable is into the system, you can refer to it later as long as it's in your main variable workspace, which is on the right of the IDE over here. And additionally, if you don't specify a variable, but let's say you just run a really simple calculation, 10 times 5, the answer is 50, and it will be assigned automatically to this value ANS, which Matlab will do. If you run a second line of code, ANS is going to be overwritten, and that value will now be whatever the new command that you wrote. So it's not a good habit to get into, and you should always try to declare those values to variable names. So here's an example. We have our prompt. We assign myVar the value of 5, and after we run that, it will give us exactly what we typed in. However, if we suppress the output with the semicolon, it will just return the prompt. So this is a good thing to do when you write longer programs and longer scripts because you don't want a bunch of text or matrices being displayed to the screen. It slows the process down. Additionally, there's some good functions that you can use that Matlab has stored. IsKeyword will tell you some keywords that you shouldn't use for variable names, such as continue. Who and whose will tell you the types of variables that you have, whether they're integer, strings, their size, are they empty, anything that might be helpful perhaps if debugging. Clear will remove workspace variables. And save and load allows you to create archives so that if you have a particular set of variables that you want to return to, you can save them to a file name. So it's useful. I'm sure all of you have seen operators or relational expressions before. However, one thing to focus on is their order of precedence, and this is how they are. This is just the example um, of a few of them. However, it's good to know, obviously, PEMDAS, and if you ever want to double check, you can look it up as well for MATLAB. And that way, when you're writing logical statements, you know that you don't need necessarily all of these parentheses encapsulated if it already has a certain order of precedence. The only two things within these lists that I'd like to focus on are the dot operator over here, which will come in handy later when dealing with arrays, and I'll be sure to point that out, and the inequality sign is a tilde in MATLAB instead of an exclamation point. Okay, so one of the first uh, types of data containers that we can use are called vectors, and they store values all of the same type. So you're either going to pass it all numbers, let's say, or you can pass it strings. But strings are better kept in cell arrays, but we won't get into that now. So let's just treat these numeric vectors. There are two forms that we can use more or less: row vectors or column vectors. This this shows one way to form a vector. You have your name, variable name, the assignment operator, and notice that I separate the values with commas and they're in square brackets. This is how you can build one method to build a vector, and this would be the output. Notice how the values are displayed horizontally. However, excuse me, in order to produce a column vector, you can simply transpose that with an apostrophe, and your output would look more like this. Now, it doesn't just change the output, it also changes the size. Meaning, if you were to call the function size on this row vector, you would get one row by 5 columns, 4, apologies, 1, 2, 3, 4. Vice versa, if you were to call size on this, you would have 4 rows and only 1 column. So it's important when doing matrix multiplication, or if you're trying to pass values into a table or an Excel data sheet later on. This is an example now of how we can access that data once it's there. So this rand I is a function within MATLAB that basically takes 3 arguments. The first one being what values can we choose from, and because I'm passing it 5, it automatically will start at 1, so it can choose any value from 1 to 5. And it will build a row by 5 column row vector, so it actually produces this result. Now, it's not crucial that you know this function, but it's just a way to easily create vectors to test if you want to try to figure out a different function, or if you want to sample something quickly. This generates vectors and matrices quick and easy. And so if we want the 4th element of that, that's like saying we want the 4th column, and it will return the number 3. Notice how we did not assign this to any variable output, and so MATLAB automatically chose ants, as we mentioned before, and when it completed, it returned the prompt. So that's vectors and vector indexing. Similarly, matrices are just combinations of these row and column vectors, and we can build and index into them similarly. In this case, I'm building a matrix row by row, where each row is broken or specified by the semicolon. So this would be your first row, break, second row. The only key thing here is that the number of elements in each row must be the same with the matrix. So you can adjust the number of rows and columns, but each row must have the same number of columns. This couldn't just end at 5, 6, 7. So this would be our output. And if we were to index into this matrix, notice we use parentheses to index into them, both with the matrices and the vectors. Then we can extract data. This format is using the colon, which says we want all values from 1 to 2 and from 2 to 3. So that means we're going to take rows 1 and 2, and we're going to take from columns 2 and 3. So we effectively get this middle matrix. So it's one way to extract more than just a single element. And so the other way of thinking about it is I and J. You're going to index into it using your row and your column number. Here's an example, excuse me, where we define 2 matrices, A and B, And we're just demonstrating quickly scalar multiplication and division, in which we're going to multiply every value within B by 2, divide every value in B by 2. We're going to multiply the two matrices together because their inner and outer columns agree. They're square matrices 2 by 2. And then here's the dot operator with exponentiation. In this case, we have to use it because we want to raise every element within A to the power of 2. And to do that, we need to use this dot operator. And so our outputs would be as such. This is what A would look like. The scalar multiplication would produce this result, simply because our matrix was 0, 1, 1, 0 to start and multiply by 2. That's where the 2's come from. This would be the division, matrix multiplication. You can do it out if you would like, and then the exponentiation. So our 4 squared is 16, 2 squared 4, etc. This page has some great functions on it that can come in handy. They're simple and easy to use. Each one of these is hyperlinked, so when the slides become available, please take a moment to look at the Matlab documentation on them. For instance, size, we talked about that before. Size will return the row and column number of any array. So you can pass it a vector, or you can pass it a matrix. So if we were to pass it A, it would return 2 by 2 because it's 2 rows and 2 columns. Similarly, these functions over here can be helpful for some of the code or the programs you might write, and they do mostly what they sound like they're going to do. For instance, this one's going to find the minimum value in the array, the maximum. This will produce a sum, so if you pass it a vector of numbers, it will sum them. However, what's important to notice and to practice is min and max, how they will behave with a vector versus how they will behave with a matrix. For example, if we call min of a matrix, it's going to give you the minimum value in every row, meaning your output is actually a vector, not a single value. So that's something to keep in mind. Strings are something that come into play as well. I don't think that they will be I don't think you'll have to do too many functions involving strings. They'll be more for writing plots, the titles, labels, dealing with patient names or hypothetical patient names, excuse me, or if you're building tables or Excel data sheets and you want to specify row or column field names. So this is just an example of declaring my text to hello world, in which this is a string of characters as displayed over here. Additionally, as a side note, if you want to use an apostrophe within a string, you actually in Matlab have to put 2 of them consecutively so that you have an output that looks like you are right. So these are strings. Selection statements and looping. These are very handy, and they are built into many of the functions that Matlab have, but to be able to write them yourself and to use them for this application, they can be a great tool to have. So to begin, the if statement. This chooses whether or not the action statement will be executed based on this initial condition. So it's basically saying, if this condition is true, execute the lines of code that are then bracketed between the if statement and the end statement. And it's important to note that you don't necessarily need the parentheses when writing the if condition. I like it because it just makes the code a little easier to follow for you and others, but they will always need an end. So for every if statement you write, there should be a corresponding end. Here's a basic example, 7 lines. We're going to call a random number from 0 to 1, random real value, and this is one way you could structure it. If this condition is true, if it's less than 0.5, display that it's less than 0.5. Otherwise, the only other option is that it must be greater than 0.5. So notice that this is an if-else end statement. You can also have an if, else if, another condition, and then an end. They all are kind of similar in what they do. It just allows you to expand upon the conditions that you may be searching for if you're looping through a file, for instance. The for statement is similar. It performs an action for a specific number of times. Its syntax is as follows. We have the main statement for, open parentheses, This I is any variable name that you would like. I prefer I, J, and K to start. You could have II, you could have ITER for your iteration, you could have variable 1. This could be anything, and it is assigned the values 1 through, again using colon 10. So this means we're essentially going to perform whatever lines of code are between the for statement and the end 10 times. At the end of each iteration, i's value will increment by 1, so you can use I within the code if you'd like. And on the 10th loop, at the end, I will have a value of 11, so the condition's no longer true and the loop will end. So this is a slightly more complicated example of a for loop. And so there are a few things going on here. To begin, let's jump right to the for loop quickly. You'll notice that there are two of them, and they're indented in from each other. This is called nested for loops. So one for loop within the other. And so what this script is designed to do as an example of a for loop is let's pretend we have a matrix that looks just like this, okay? We're going to generate this 5 by 5 matrix. And we want to loop through this whole matrix, and we want to know how many ones are in here and how many zeros. And so what the code on the previous slide will show, or is designed to do, is for every row in this matrix, it'll start here, and it will go down the column. It will then test the value that is here to see if it's a 1 or 0. If it's a 1, it will count up for the 1 variable, and if it's a 0, it counts up for the 0 variable. When it completes this line, it moves down another row and moves across again. And it continues until it ends right here on the last element of the matrix. So to look at the code a little bit more, that matrix is generated with the randi command. Again, it's going to create a 5 by 5 symmetric matrix. If you don't pass a third argument, it creates a symmetric matrix with values from 0 to 1. This is a vector here. You're telling where it starts and where it ends for values it can choose from. Additionally, we're initializing a 1's counting variable at 0, a 0's counting variable at 0, and we're determining the size of this matrix. So we know it's a 5 by 5. However, you're not always going to know the size that you're passing into a function, let's say, or the size of the matrix that you're operating on. So it's good to make it as general as possible, and that's why this function is useful. So this is going to be the number of rows and the number of columns that size returns. So we're going to loop through the number of rows, and then moving down the columns, we're going to get stuck in this for loop as we move down the columns. Now here's our important relational statement, an if-else statement that's going to test each value. So it's going to take the I and J element. So notice I will be fixed when we're in this for loop, but J will keep incrementing through the number of columns before I increments back to the next row too. And so once we're testing an index, if it's 1, we count 1, otherwise it must be 0, so count 0. And we'll repeat this through all 25 elements of the matrix and print the results. And so when it was done, it said there were 13 ones and 12 zeros with a 1s to zeros ratio of 1.08. So this is, again, a nested for loop with variable initialization for counters and an interior relational statement. So it's a good example of what you can do with matrices. Similarly, the while loop or while statement is another form that we can use in our code, and it will perform the action that's in between the statement and the end bracket so long as whatever condition is being met remains true. So if we were to apply it to this example, let's say we had a target value of 24, and we want to generate with this line 3, we're going to generate a random number between 1 and 100. Additionally, again, we're going to initialize a loop count variable of 0. And we're going to say while our random number that's being generated is not equal to our target, well, generate a new number and increment the loop count by 1. So we're not going to count this test, but it's going to say, are they equal? If they are not equal, then we need to keep testing. So this condition is actually true, and we'll call a new number and count up. And so the result looks like this. It took 142 attempts to guess the target number. So you could write this code yourself right from the slides and run it. Perhaps you'll get it in 2 attempts, perhaps 5, perhaps 300. Each time you run it, you'll most likely get a very different value. So now that we know some of the basics for variable declaration and data containers, vectors, and arrays, we should focus on writing programs. So program files will always end in .m, and they will be written in your editor in the IDE, which was that center box. So technically, it's just a sequence of MATLAB instructions that's stored in a particular type of file and saved. It can be run at any time as long as it's within your path. And this is what the top of your IDE will look like, or the program window. You can go new, and it'll give you an option for a script. And then within the editor window, when you're done writing that script, you can click the run button, and that will execute all of the lines of code. I'd also like to point out that as you write programs and functions, you should really get used to writing block comments. Block comments are written anytime you use a percent sign, shift 5 percent sign. Anytime you use that, whatever text, be it numbers, characters, words that follows, will not be executed by MATLAB. They just show up as hints or pointers for individuals who are reading your code, or for yourself to remember why you wrote a particular for loop, let's say. It's a good way of explaining your code and keeping track. On the other hand, we can write functions. Functions are different than programs because they take an input and they pass an output back to the main calling program. They also have a little bit more structured approach to being written. So anytime you write a function, line number 1 will pretty much always look the same, just like this. You will start with the keyword function, followed by your output vector. You could have one value here, just out1, or you could have a vector of outputs. Assignment operator, get stats, and the input. Now, get stats is the name of the function, and this must match the file that you save it as. So when you save your function, it should be getstats.m. And input, this is the value that you'll pass to your function. So you could send in a row vector, for example. Now notice, these are the comments that I mentioned in the previous slide, and it's helpful to explain what the input structure will be and what the outputs will be. And when you call help is a keyword, a key function within MATLAB. If you call help and then get stats with a space between those 2 words, you will get this block comment returned to you. So you can instantly know what it is that this function does, who wrote it, whatever it may be. Okay, so next is the function body and the end bracket. Notice that I'm passing out the values data mean, median, and mode to out 1, 2, and 3. Now you don't have to do it this way because you're essentially passing values from one variable to another. However, I like to keep these outputs separate and at the end of my function so that I have all my calculations being done in the body and then I pass it out at the end. But that's up to you, it's a preference. So this is an example of what your output would look like. Help get stats returns the information we may need. And then if we created a random vector, this is how we would call the function. So these are output variables, equal or assigned to the function's output get stat as we pass in the random vector. The only thing I'd like to make a point further is that the order in which you pass these out must match the order that you're expecting them, meaning the first one is going to be a mean, median, mode in that order. So when we assign them, we want to do the same, average or mean, median, and mode. Additionally, you can write functions within the function body. These are called nested function, and allows us to consolidate and keep the code a little bit more organized. And so this is a hyperlink, the link that if you want to see a few more examples besides this one right here. So essentially what we do is we have an exterior outermost function, calc volume, which has 3 inputs and 1 output. Within that function, we have a nested, notice it's indented on line 6, called out2, I'm sorry, its output is out2, but its function name is calc area. And so the way this works is to focus on the variable scope. So most of what we've been dealing with so far, the variable scope is your main workspace. So anything you write in a script, anything you do in the command prompt, your variables are in your main workspace and you have access to them. However, when you write functions, those variables only exist within the function so long as the function is being executed. Afterwards, the variables are destroyed and they're no longer accessible within the main workspace. However, with nested functions, you don't have to pass these values to the interior function. They already have access to it. They're all in the same scope. So that's why I pass in the length and width, let's say, and this second function can access those without passing them as inputs. So the way this works is you would call calc volume, you'd pass in 3 inputs. You'd have a second function that calcs the area, returns it. So V is going to be our volume equals calc area. It's going to return the area times the height. So length width height will give us the area, and we will pass that out from the main function. So if we were to run it with 1, 2, 3, our volume would be 6. Also, variables within the inner function can be used in the outer function, so it works both ways. Another key function that Matlab has that will be useful for reading from Excel files into a structure that will be easy to use is called read table. It'll allow us to take either a text, a CSV or comma separated value, or an XLS, for example, file, and turn it into a table. So what is a table? Well, it looks just like this. In this case, we're assigning T to be our table from the read table function. We're passing it a string, all strings. This is a file that's in our workspace. This is the format. So this is a little bit more complicated way, and you can take a look in this link. It's not always necessary. If we passed it just the data file, it would do the same. However, it can be useful to understand this notation, where you're basically saying we're giving it a string, an integer, 2 doubles, and a string, where each one of those is a type of data. And notice here we have string, integer, double, double, string. Another method to generate a table from an XLS file is to pass it in a similar fashion. However, this time we're going to specify that we want it to read the row names. So now we don't just have the column names, but we have the row names. So these are no longer fields or data points that you can directly access. You can still access them, but they're not so much elements of the table like they would have been here. Additionally, we can index into the table with this same notation, and this would create a smaller subset table. So continuing with indexing and tables, there's 3 ways that you can extract data into a new subtable. One is the numeric indexing. So we're going to do it just like we would with an array. We're going to take the first 5 rows. And whenever you pass a colon as an argument, that means, okay, for the first 5 rows, take all of the column data. So that's just a way of saying it's an include all. So that would create one subset table. An alternate method would be to use variable names. So either your column names or your row names. Again, and give me all of the column data for these 2 rows. Notice the curly braces. This is a cell array. I briefly mentioned this earlier. It's one way of passing multiple strings. So this would be one second format. And the third would be to pass logical expressions. So we could say rows are the patient's age less than 30. So any patient that's younger than 30. And we want to look at the column names gender, height, and weight. We can then pass those 2 variables, one being a logic statement and one being a cell array. And we could produce a third table that is a subset that gives us all of this data for patients under 30. So again, curly braces versus parentheses. There's another link to cell arrays where each cell array can only contain, I apologize. Cell array can contain any type of data. So that's why they're a little bit more useful for things like this. Finally, you can also use the dot operator to extract data directly from the table, meaning we're not going to create a subtable or a subfield. We're going to actually take out the elements. So if you want all of the data from the example table for patients under 30, and you want to know all their height, this would be one method. So you're saying patients.height would normally return all the height data for every patient, but then we're going to pass it in these open parentheses, this logic expression, only focus on the patients whose age is less than 30. So this would return a vector of data, of integer values. Another feature within MATLAB is working with date and time, and that's going to be common for some of the examples that we'll be doing for homework, in which you have a sequence of dates and you want to know the time between them, let's say, or you're trying to figure out how long an activity is taking. So understanding the date format will be helpful, especially when translating or transforming between Excel and MATLAB. So one form is called serial date numbers, and they appear like this. A single number is equal to the number of days since January 0, 0, 0, 0, 0. So it looks funky, but it's the same thing as if you were to see this date string. So this is serial date numbers. We have date vectors, which could be a 1×6 vector of double precision numbers, meaning the first will be your year, month, day, hour, minute, and second. So this will give you actual values that you can perform calculations on if that's what you needed. Or a date string. This is kind of how you would rather present the data. It's easier to interpret, but it's not easier to perform calculations on or time between 2 dates or 2 periods. So for example, if we had this table that I made in Excel really quickly with dates, this is I believe their default format when you format the cells. You can say T equals read table, and we're just going to pass the file name with no other arguments. So it's really simple. And that's going to take the first row and treat those as field or variable names. So that's ID and date, and then the values that it contains. So integer values and string values. So this is one way of importing date and time data from Excel to MATLAB. Additionally, if we wanted to convert that data, in this instance, we're converting it to a type date time. It's a type of data, much like integer or float, double, string. Date time is its own type. So we're going to index into the table with the dot operator for the values and say, well, all of the date values equal, let's assign them. Date time is a function. We're going to pass them the values again, and we're going to convert them from Excel. And so that's one way to convert. A second is to use the date num, which is the other type that we mentioned. Again, we're just overwriting the date column by converting the date from this string format to this, the serial date number. And so that could then allow us to do something like this. If we wanted to know the numbers of days between, we could say, well, we're going to use this colon operator again to call the first date in the table and the last date in the table in serial date form. And it will basically create a vector from all the values from the first to the second. Now, the last thing we will do is this function that MATLAB has called numL, which is on one of the first few slides, that returns the number of elements within the vector. And so this is not the easiest or more straightforward method of finding the days passed, but it demonstrates a lot of what we just talked about. And so there would be 731 days. I believe the new MATLAB, the 2016 edition, which is what you're most likely downloading, has a few built-in functions to already do this. I can't remember the names of them off the top of my head, but if you search within the MATLAB documentation for days passed, they should come up right away. And so the last feature, sort of for this broad view approach to MATLAB that I'd like to focus on, is very useful. It's debugging. It can be extremely helpful when you can't figure out where your logic is flawed within your for loop, let's say, or you're having trouble reading data from Excel into a table, and you want to visualize what's going on. This is a great resource. So the first step is you're already in the editor because you're writing a program. This grade piece, the column here is called Breakpoint Alley, and you can go ahead and click at any line with your cursor, and it will place automatically this red breakpoint. So when you go to run the function, you'll actually get this new menu bar, and the program will pause at line 6. It will not execute this line until you tell it to. So one option at this point is you can hit step. Step means we will now run the program line by line for every click of this button. So after we press step, line 6 will have been executed. And now what's very interesting is we can hold our cursor over mat, our variable, and it will actually display on your screen the values that are being contained within the matrix. Now with small matrices, this is great. 5 by 5, no problem. When they get a lot larger, you're more interested in whether or not what their size is and are they null, because that could be a problem right there. So you can continue with the function all the way down to this line. And I recommend doing that with this particular script because you can watch with this for loop, let's say, how the variable num will be incremented for each time you press the step button. Similarly, when you get down to line 17, this is just a random function I wrote for a demonstration purpose, but it's called debug function 1. And whenever you reach, your breakpoint reaches a function, you have the option to step in. Now, when you step in, it will actually go into this other function you have written, and it will give you the green arrow in here, which means you can execute each one line by line by pressing the step button at that point. So you can go run through line 4, 5, and then eventually it'll ask you if you want to step out. You could also step out ahead of time if you determine that that function is not necessary to debug. Additionally, you can press the continue button at any time, and that will proceed with running the code all the way back, let's say if it's looped, all the way back to the breakpoint, and then it will stop again and give you the option to step in. On the other hand, if it's not a looped program and you click continue after the breakpoint, it will just finish and execute or break depending upon what's going on. So that more or less sums up the introduction to MATLAB section that was held in last week's class. I have this last slide that I think you will all hopefully gain some knowledge from. It covers steps such as installation, some more introduction material. Tutorials Point is a great website. I use it regularly for all sorts of code, and it can be a great lookup and reference if you wanted to quickly get a visual of a for loop, or if you wanted to look up some functions, even MATLAB built-in functions that you needed assistance with. Additionally, MathWorks has some good documentation on file input-output or import-export, kind of like what we're doing with the Excel tables. And finally, there's some great examples that cover anything from linear regression to signals and processing, which we won't be doing in this class, but it has quite a few that you can pick through that may or may not be helpful throughout the semester. So thank you all for the first week and first class. If you have any questions on any of this material, feel free to either consult these links or send the TAs an email, and we'll be happy to help. All right, thank you.